Hello friends, welcome to EC Academy. In this lecture, let us understand steady state response in network theory. We'll understand the concept of steady state and we'll relate this steady state with the initial conditions and we'll understand how to use this for solving the problems. So what is a steady state? Let us start with a simple idea. When a circuit runs for a long time, which means t tends to infinity, the circuit will become stable, and this condition is known as a steady state. For example, if the circuit is on, things keep changing initially. After some time, everything will become constant. This final stable condition is known as a steady state. I hope this concept is clear. When the circuit is running for long time, at t is equal to infinity, the circuit will become stable, which means after some time, everything will become constant in the circuit. Such state is known as the steady state. There are two important time points in the circuits. First one is initial condition, which we have already understood in our previous video, which is t is equal to 0 plus. This condition is just after switching. This condition is just after switching the circuit on. And in initial condition, sudden changes are not allowed. So in initial condition, sudden changes will not happen or sudden changes are not allowed. The second time point is steady state, which is t is equal to infinity. Steady state happens after long time, which means it will happen when the circuit runs for long time. Here, no changes happen with time. So if we say no changes happens with time, it means all electrical quantities in the circuit will become constant and it stop varying with respect to time. So it means current does not change, voltage does not change, everything will become stable. So to fully understand the circuit, we must know the initial condition, which is what happens at the beginning at t is equal to 0 plus, and steady state, which means what happens at the end at t is equal to infinity. Now let us understand the concept of steady state for a resistor. Here, resistor is the simplest element, and you need to remember the resistor does not store energy and it has no memory. Hence, in the steady state as well as in the initial condition, the resistor remains the same. So, there will be no effect on resistor for both initial condition and steady state. Now, let us understand the steady state response of inductor. The voltage across the inductor can be given as VL is equal to L di of t by dt. So from this equation, we can understand that the voltage across the inductor will depend upon how fast the current changes. So at steady state, the current become constant. So the differentiation of current di of t by dt will be equal to 0. Therefore, the voltage across the inductor will also be equal to 0. This means the inductor behaves like a short circuit. So the inductor behaves as a short circuit at steady state response. So if you can remember, at t is equal to 0 plus, which is at initial condition, the inductor will behave as open circuit since current cannot change suddenly. So for an inductor, we can say at t is equal to 0 plus, it will act as open circuit, and at t is equal to infinity, it will act as short circuit. So this is very important concept which you need to remember. Now if we consider a capacitor, the current through the capacitor can be given as I is equal to C dV by dt. So the current in a capacitor will depend upon how fast the voltage changes. So, at the steady state, the voltage become constant. Therefore, dV by dt will be equal to 0. So, if we differentiate constant, we will get 0. Therefore, the current in the capacitor will also be equal to 0. So, this means there will be no current that will be flowing through the capacitor. Hence, the capacitor act as a open circuit. So, in steady state, the capacitor will act as open circuit. At initial condition, if you can remember, the capacitor is a short circuit. So, finally, we can say for a capacitor at initial condition, it will act as a short circuit, and at steady state, it will act as open circuit. This is very important concept for solving the problem. Now let us understand some important points which are very important for exam. The first point is that the inductor current cannot change instantaneously. Next, the capacitor voltage cannot change instantly. So, at initial condition, the inductor will act as open circuit and the capacitor will act as short circuit. At steady state, the inductor will act as a short circuit and the capacitor will act as open circuit. Now let us understand the initial value replacement concept. Now this is very important concept. At t is equal to 0 plus, which is initial condition, the inductor with initial current I0, we need to replace the inductor with current source and the capacitor with initial voltage V0. We need to replace the capacitor with voltage source. This is very important when we are having some initial value. Now, how to solve circuit at initial condition t is equal to 0 plus? We'll understand this step-by-step method. First, we need to replace inductor with open circuit and the capacitor with short circuit. Then we need to apply KVL or KCL. Then we need to solve for required current or voltage. So this is very simple. To solve the circuit for initial condition, we need to replace inductor with open circuit, capacitor with short circuit. Then we need to apply KVL or KCL and we need to solve for required current or voltage. Now how to solve the problem at steady state, which is t is equal to infinity. First we need to replace the inductor with short circuit, then the capacitor with open circuit. Then we need to solve this circuit normally to obtain voltage or current. So today we understood what is steady state, what are the initial condition and the behavior of resistor, inductor and capacitor. This topic is very important in solving problems in exam. Hope you have understood the topic. Thank you.